This is 2023 paper 2 question 2. We're told to prove this identity. The way that the identities kind of work is you prove this one using some trigonometry, and then the rest of them are kind of built off of this one. So when we see one that's not the cos of a minus b, we know that we can prove it using some other identity. So the one we're going to use is cos of a. We could use either a minus b or a plus b. I'm just going to use a minus b to be safe because that's the one that you derive using trigonometry. So essentially what we want is to use a fact, because we don't want cos of a minus b, we want obviously sine of a plus b. So in order to turn this from a cos into a sine, we can use the fact that if you have cos of 90 minus some angle, that's equal to sine of that angle. And let's just see what the definition of cosine and sine. So if we want to figure out what sine of a plus b is, and then we want theta to be equal to a plus b, right? So what we want is we want cos of 90 minus a minus b, and that'll be the same as sine of a plus b. I just multiplied out the minus onto the a plus b here. So this is kind of what we need. So if we look into our equation, what we would kind of like to have is if we replace this a with 90 minus a. So instead of using a and b, what I'm going to do is I'm going to write this out using x and y just so you don't get confused. So this is a fact for all x and y. So I'm going to say that cos of x minus y will be cos x cos y plus sine x sine y. And again, I'm just doing this so that you don't get confused. So now I'm going to let x be equal to 90 minus a, and y will be equal to b. And then we'll get cos of 90 minus a minus b, and we know that that's the same as sine of a plus b. Okay, so I'm going to fill into this. So we'll get cos of 90 minus a minus y, which is b, which will be equal to cos of x, which is 90 minus a, cos of y, which is b, plus sine of x, which is 90 minus a, times sine of y, which is b. So this part here, we said that that's the same as sine of a plus b. That's just because it's 90 minus a plus b. So this will end up being sine of a plus b. That'll be equal to, so cos of 90 minus a is sine of a. That's just by the definition of what cosine is, times cos b, plus, and then sine of 90 minus a, again, by the definition of sine and cosine, that's going to be cos of a times sine of b. And then I believe that should be what the identity, we were asked, sine a cos b, yep, plus cos a sine b, that's exactly what we have, so we are done. Then we're told to find what the value of sine of 75 is without using a calculator. So the idea is we're given what sine of certain values are in the formula and tables booklet. So how could we make 75 out of those using a plus b, remember? Well, 30 and 45 would work, okay? So instead of saying sine of 75, we would like to use the formula. So we can say that's sine of 30 plus 40. And subbing into our identity up here, well, sine of 30 plus 40, I'll just drag this down. So that'll be sine, or sorry, 45 that should be, so then they add up to be 75, and there are also two numbers that we know from the tables book. So we'll get sine of a, so we'll get sine 30 cos 45, and then we'll have plus cos a, which is 30, so cos 30 times sine 45. And then we can figure out what those values are. So if we look at the table, sine of a in 30 degrees is going to be a half, so we'll have a half. Cos of 45, reading off the table, is 1 over root 2, plus, and then we'll have cos 30, which is root 3 over 2, and then sine of 45 will be 1 over root 2. Cool. And we can just simplify a little bit. So we can just kind of multiply it out. So this will be 1 over 2 root 2 plus root 3 over 2 root 2, which is equal to root 3 over, well, root 3 plus 1, sorry, over 2 root 2. You might want to rationalize the denominator just because I don't know if they're, well, they say give your answer in surd form. It's just a good idea. We don't like to have irrational numbers in the denominator. So you could put this into your calculator, it'll simplify it for you, or multiply the top and bottom by root 2. If you multiply the top and bottom by root 2, what you'll get, well, root 3 times root 2 will give you root 6 plus root 2 divided by, and then root 2 times root 2 gives us 2. So this is 2 multiplied by 2, which is 4. And that's going to be our answer. Then we're told to solve this equation. So the problem is that we have sine of two different angles. So it would be nice to use an identity here. We can use the fact that sine of 2a is equal to 2 sine a cos a. That'll help us here. So that means that sine of t is equal to, we can say that's 2 sine t cos t. You might be tempted to divide both sides by sine t, but if you know anything about solving an equation, you'll know that that's not a good idea, because that can cause us to miss solutions. For example, if 2x squared is equal to x, you could divide across by x and say, oh, well, clearly x is going to be a half. But the thing is, x equals 0 is also a solution, so that's why it's better to bring everything to one side and factor. That's what we're going to do here. I'm going to say 0 is equal to, and I'm going to factor out a sine t from the terms, and then what we'll get is 2 cos t minus 1. The minus 1 is coming from bringing this to the other side as a minus. So that means that sine t equals 0, or 2 cos t minus 1 is equal to 0. So if sine t is equal to 0, obviously that means that t is equal to 0. So that's one solution. And then if you think about the unit circle as well, so if t is equal to 0, well then that means that we're here. And remember that sine is going to be the y-coordinate. Okay, so where else do we have the same y-coordinate? Well, the answer is here. So that means that t equals, and this is 0 degrees, that means that t equals 180 degrees will also work, and also so will t equals 360 degrees, and I believe they're all within our domain. Yep. So there are 3 answers that we get from solving this equation. In terms of solving this equation, we'll get that cos t is equal to a half, and we can solve this one. So t is going to be the cos inverse of a half, so figure out what that is, and you'll get 60 degrees. And again, we have to check for our other answer using the unit circle. So basically, 60 degrees, what that means is we rotate up here by 60 degrees, and cos is the x value. So where else will we get the same x value? Well, if we rotated down by 60 degrees, because the circle is kind of all symmetric, if we're moving to the left here, rotating 60 degrees, the x value is going to be here. And here, if we rotate down, we're still moving to the left by 60 degrees. So our other answer, it's going to be, well, it's going to be the whole thing, which is 360. So this is 360, but we only want to figure out to that red line, so this pink part, so it's going to be 360 minus 60, which is 300. So our other answer is going to be 300 degrees. And then we can plus or minus 360 onto these, obviously, but that'll bring us outside our desired range. We did add 360 onto the 0, though, because 360 is within our range. So here's all our answers. We have these, and then we have these two as well.